Welcome back to another video. We're just finishing up the last portion of our math section where we're going to talk about our significance level. So we talked about p-values before and how to find that, right? And everything that's associated with this. But now significance level is kind of another section, so think, okay, now we're just kind of doing a similar thing but for another section. Here we go. Maybe here we don't go. Here we go. A significance level, let's talk about it. So, a significance level is the value selected before any data is collected. It's before. You're going to pick it before and you're saying, okay, what is going to be kind of my rejection region before I start? That's going to indicate what is small for a p-value. So you pick that before, then you go and take your sample statistic, you turn it into a test statistic, and you look at the p-value based on this, and you pick it at the beginning. The common symbol that is used for significance level is beta, little fish guy. The most common significance level that you'll see across the board is normally 5%. They'll normally give it to you as a percent. I mean, again, really, that's just saying that your beta, like the area, should be less than, a lot of times, 0.05. That's considered small. Okay? The significance level is a probability, and it's also an area. We've discussed this a little bit. Okay? The significance level can be shaded on a t-curve or on a standard normal curve, and that is what I have already told you as well, and I'll show you that in a moment again. The shaded region is often referred to as the rejection region. And what also happens is it's the location where the shading ends is called our critical values, and those are your t-stars or your z-stars. And so if you go back to the picture that I gave you at the beginning of the unit, here is your significance level right here. That is your rejection region, and it's based off of your little beta guy. It's also, we need to determine our critical values using that. And this is what we pick first. So you have to pick this first and then go find this. Okay? And so that's kind of where we're going to go. So first thing is first, if we're using a calculator down here. If you're using a calculator, there's a couple different things we're going to look at. First off, sometimes you'll have the situations where you're going to be in a proportion problem. In those cases, you're going to want to go figure out what your critical values are, z-star. And other times it'll be a mean setting, and in those cases you're going to want to go find out your critical values there, which again are t-star across the board. So how we do this is you are going to be given, again, some sort of alpha, some sort of significance level, and if your alternative hypothesis is less than, you are going to kind of mark that, you'll know the area, and your job is to go find out what that z-star is that goes with that. How we're going to find the z-star is you're going to have to work backwards and use inverse norm. So again, if you look at inverse norm is when they give you an area. We haven't used it in a little while because this is a normal curve. You would type in the area and then you would hit enter and a whole bunch of stuff, and it would pop up with your z-star. Okay? So we're just going to jot some of this stuff down. So what you would have to write in here on your calculator is your area, so your significance level. The 0 is already there and the 1's already there for you. If your alternative hypothesis was a greater than symbol, well, you would have the area, they would give that to you in the problem, it would be your job to then go find the z-star based on that area. How you're going to do that, again, you probably are going to have to take, it's still the same exact thing that you would type in. I put the absolute value here for people that have older calculators, because if you have an older calculator, you can only type in the lower tail, and it'll always be on the left. If you have a new calculator like this, you don't have to necessarily have these absolute value marks. You could just change it, like if it was 0.05, you could just change it to be on the right, if that was you for this type of problem. If it's not you, just keep it on the left, it's okay, and you'll need your absolute value signs. If your alternative hypothesis is two-sided, you'll have to split your p-value not your p-value, you have to split your significance value or level to both sides. So this will be half of my significance level on one side, and on the other side you would have half of your significance level on the other. And we're going to do some examples, and hopefully it makes more sense here in a moment. And so you would add or subtract, like when you type this area into your curve, you're only going to do one of the sides, and it's going to be half of that. So you'd want to do one of the areas over here. You would type in half of your significance level, and you would still keep 0 and 1. You would just have to make sure you have the positive and the negative sides of that together in order to figure out what this z star was and this z star was. You would want the positive and negative version of that number. This is still very similar to if you had, instead of a z star, you had a t star. Again, they are going to, if you have an alternative hypothesis that's below, they're going to give you a significance level. They're going to give you that area below, and they're going to ask you to find out what that t star is. You'll need to know what that is. And just like we used inverse norm up there, you're going to want to come through and use inverse t. That is right here. Right underneath inverse norm. Again, you would just have to type in the significance level, the area that they gave you, and you're going to have to type in your degrees of freedom there. Again, if you have your older calculator, a lot of times you can only type in the tail, but for this new one, they're still going to give you your area. You'll be expected and need to find t star on this side. If you have an old calculator, if we come back out here, oh sugar, I've messed this all up. If you ever get like weird errors on your calculator, just type in random numbers and hope for the best. Like this is still jacked up. Like I don't know what the heck I did. You'll get an error, hit clear, and then if you go back and try it again, like that, it's still there. I don't really understand. I guess we can just try to type in something else later and it'll be fine. Okay, sorry. Still the same thing. You're going to want the positive version of whatever pops out. Still the degrees of freedom on both sides. And again, this is similar. If they give you a two-sided alternative hypothesis, you're going to want half of, I don't know why I put negative, half of your significance level on one side and half of your significance level area on the other side. And they'll want you to find the t stars that go on both of those sides. Okay, and the way that you would, again, would do that is you would just take this area. I don't know why I didn't make it a half. You would type this in, half of your significance level, and then your degrees of freedom, and you would just want to make sure that you have, so that will give you one of your t stars, and you want to make sure you have the positive and negative on both sides. Now, if that was confusing, hopefully when we put it to action, it'll be nice. So let's try some. So it says examples for finding z star and t star. So it says suppose for a z test, I'm going to want to find z star, and it's going to be a normal curve, right? Suppose the significance level was set, so this our significance level is our little beta friend, is set, oh it's right there, at 0.05. It gives us some other information, it gives us our null, and it gives us our alternative hypothesis. It asks for what is z star. So you don't have to go crazy with this. I'm just going to go and put that straight on here right away. So I'm going to say, all right, my significance level, my area, I know out here has got to be 0.05, and I'm looking for what t star is. So I need to go figure out what this is. The reason, again, that I shaded below is because my alternative hypothesis tells me to shade below. This out here is my rejection region, just in case you forgot. Anything out here is going to be significant. Also, if you wanted to put in here, that's also your little beta friend. So because this is a z problem, I would go to second bars, and I would go to inverse norm. And it's stuck on this. Why does it have to be like this all the time to me? Okay, let's restart. Okay, so I would go to inverse norm because it's a z test, It gives me my area that I'm going to type in. I'm going to type that's my significance level. Keep everything else exactly the same, and it's going to pop out a beautiful number. So my z star is negative 1.645. Gorgeous. Gorgeous, gorgeous. Okay, again, if you want to type in what you did, you went to inverse norm. Struggle is kind of real today. Hopefully it's not for you. Okay, well, let's keep going. Skirt, skirt. Let's try this one out. It says this time we are doing a t-test. T-test means I'm going to want to find t-star. And it's giving me a significance level this time. It's smaller. It gives me a null and an alternative, and this time I see the alternative is greater than. So we're going to look for t-star. Over here, I know that the area, shoot, I should make it tiny. The area that they gave me is the same thing as whatever your significance level is. So a very tiny area, right? And we're shading above it because that's what my hypothesis, my alternative hypothesis says, and we need to go figure out what the heck t-star is. So from before, I am going to go to second bars. Inverse t this time, my area is 0.02. My degrees of freedom, remember degrees of freedom is, I'm brain farting, n minus 1, and so that would be 19. Okay, so I'm going to type in 19. Alright, my t-star is, and then this is where the absolute value comes into play. So maybe you put on here that you did inverse t, but you have to do the absolute value of whatever pops out here, because this is definitely not on the negative side. So 2.2047. Okay. The very one, last but not least, you're going to rock it out of the park. Hopefully you've already even done it before me. You guys are so fast. Let's look at this one. We got a z-test. Z-star is what we're going to be looking for. I know that I want the area altogether, my significance level, to be this. However, this time we have a two-sided test. So two-sided tests aren't hard, you just have to be aware of what you're doing. That means I need to take my significance level, that area, and split it up into the two sides that I want. So just divide that up into two. That means on this side, my area is going to be 0.025. If you want to make your note to self, it's half of your significance level on this side. And if we go to the other side, we should have it kind of mirrored the same way. We're going to have half of our significance level area, and that is going to be 0.025. Okay, so now that we have those, we are going to want to find, this is a z thing, so we're going to want to find z star on both sides. So when we go to the calculator, you just focus on one of the sides. I'm going to pick the negative side. So if we go second bars and z is inverse norm, the area that I have is 0.025. That looks good. Enter. It's on the left is what I'm figuring out. Paste. So here is my t-star on this side. Shoot, I forgot the negative sign. Negative 1.95996. Well, that's going to get rounded a whole bunch of times. I'm going to go with that. Okay. And then on this side over here, it's just going to be mirrored over. So that is just going to be that. And again, if you kind of look back to the page before, it might have been written kind of confusingly, but it was just for people that really just need to know. Think about it as your textbook. If you got this, you're amazing. You go. Smile.